Hey everyone, and welcome to part 22 of the Godot top-down shooter tutorial. My name's Joe, and in this one, which is an optional video, so you can skip it if you don't want to collide with other units. You don't want your AI to take into account the path or other units in their path. But in this one, that's what we're going to do. Similar to how we did in the last video with walls, we're going to dynamically update our navigation grid so that it accounts and disables certain tiles where enemy units are on. And I'll also discuss some other better, more performant ways that you can implement the same effect if that's something you want to do. So I hope it's helpful, and with that, let's get started. Alright, so before we get started with this video, I do want to give a disclaimer, which is I'm not actually sure this is the best way to implement dynamic collisions with other units in your game. And the problem mostly lies with the fact that we are using a tile map that is 64 by 64 pixel cells. And what that means is that our units are actually smaller than that. And because they don't move they aren't locked into a specific tile, they can move in multiple tiles. That means they may be taking up multiple tiles at a time. And the algorithm we've written so far will basically only block off one tile at a time. So you're going to see that if we, as this video progresses and we finish it, that we will successfully have pathfinding that avoids other units, but sometimes they can get stuck or get a little jittery just because it's not always easy to detect the fact that units are taking up multiple tiles. And if you do add handling to that, I tried doing it in preparation for this video just to see, it can create a whole other host of errors because then you're blocking off tons of tiles and making it so that the AI has to take really suboptimal paths. So all that to say, this is not a bad way to do it. It'll get you what you need, and you can do some tweaks to really make it feel good and work well. But I think that if you really wanted good, high-level collision avoidance with other units, you would keep your pathing algorithm probably that just takes into account walls and that's it, and it would still create the same paths that it's doing as of this moment before we start implementing this. And then you would use other ways to help prevent unit collisions with each other, such as steering behaviors, a little bit of an avoidance force so that if units collide, they kind of push off each other a bit so they can still move past each other. A little bit of a bounce, for example. Really just some like hand-rolled collision logic just to kind of help it feel a little bit more natural, which I think I mentioned last video is something you'll see in a lot of games. So I just wanted to give that disclaimer. What we're going to do now in this video is going to be great. It's going to be really helpful, and it's absolutely something you could run in your game and you could tweak and optimize to really make production ready for whatever you're trying to build. But there are other options, and they might be a better option for your game. So just keep that in mind. Don't feel like this is the only or the right way to do that. But with that, enough introduction. Let's get started and get right into coding. Okay, so last video, we added our walls tile map to the obstacles group. Now we're going to need to do that for all of our actors. So for our player, we're going to need to add this to our obstacles group. We're going to need to do that for our enemies. We'll add obstacles here. And we'll do it for our allies. Obstacles. Okay, and so what this means is that now in our pathfinding script, if I come in here, we're going to see that all of a sudden this obstacles array is going to have some stuff in it. It's going to have all of our enemies and allies. And now we're going to need to add some handling here so that our path takes into account that tiles that are occupied by an enemy or an ally are actually blocked. And we'll need to update it based on that. So the way we do this is going to be slightly different from how we did tile maps because we don't have to find the tile coordinates first. We just need to convert from the world coordinates of this kinematic body 2D. We need to convert it into our grid coordinates itself. So that said, we'll say var tile coord or grid coord. I apologize. I know I kind of flip-flop in between using the terms tile map and grid map or navigation map. And they're kind of technically interchangeable, but when I do that, I don't mean tile map in the sense of like a visual tile map. I just mean tile map because we are basing our grid navigation system off our tile map. So I know that's been a bit confusing, but hopefully you've been able to bear with me. Almost always when I'm talking about that in the last couple videos of pathfinding, I mean our navigation system. So we're going to get our tile coord or our navigation coordinate, same thing. And in order to do that, we're going to say obstacle dot, oh, whoops, sorry. I was thinking of our tile map. So we'll say tile map dot get, oh, whoops, geez, world to map. So, and then this will be obstacle dot global position. Actually, we'll change that in a second. But so basically what we're going to do, again, because we're using our visual tile map, our ground tile map, as our way to know where, like, it's basically the underline for how we're generating our navigation system, our grid. We can use that to convert from world coordinates to the specific part of that tile map that this kinematic body, whatever it is, enemy, player, ally, is on. So we're going to get basically the tile coordinate of the tile that that unit is on. And if I open up our enemy, for example, you'll notice that, so like I said at the beginning, it's going to be hard to get precise collisions because a enemy or an ally or a player could be in multiple tiles, or they could be in one tile. So we need to kind of think about where we are getting, how we're determining which tile a unit is on. So if we get our enemy's global position, it's going to be this right here, this one here. But if we use our collision shape, it's going to slightly more accurately represent the middle of where our enemy is. So I think instead of getting the position of our enemy itself, we want to get the position of our enemy's collision shape. And in order to do that, I'm going to say on ready var, this is in our actor script, which is shared by our enemy and our allies. So I'll say collision shape, and we'll just get our collision shape. So we've got that for our enemies and vicariously our ally too, because it's the same script. So we'll need to do that for our player as well. So on ready var collision shape, and this will be collision shape. So again, it's a small change. It doesn't really matter. You could just use the global position of our kinematic body that we're getting, but I think I'm just going to use collision shape just to be a little bit more accurate. So what this is going to do is it's going to get the tile coordinate of the tile that our kinematic body is on, that we're looking at right now. Then similar to above, we're going to need to get our tile ID or our vertex ID within our grid. So get ID for point, and this is going to be tile coord. And then we're going to say if a star dot has point, again, just making sure that we are in an actual valid navigation area, which should always be the case, but just better to handle it than not. We'll say a star dot set point disabled ID and true. So now with that, it should be taking into account the fact, or it should be marking tiles that enemy units are on as being disabled. And so if I run this, we'll see it in action. And again, like I said, you might notice some bugs or some jitters, even though they'll get out of each other's way. And oh, what did I do? Okay. So when we're calling world to map here, I'm trying to pass in an object, but it's expecting a vector, which is my bad. I'm pretty sure that this needs to be collision shape.global position. So we're not passing in the collision shape itself, we're passing in the collision shape's global position. So that's my bad. Okay, so now if we run this, we should see that the paths are getting updated whenever an actor steps in the way of another one. So you see how this guy tried to go around there. I think this is, yeah, that was messed up because he was trying to go diagonal. So that's the thing, right? If I try and illustrate that by coming here, say that there is a unit here. Oh, whoops, that's not what I wanted to do. Say that there's a unit here, right, in this tile I just colored in. And we have another unit who is here, and he wants to get here. Well, because we have diagonal connections, our navigation system is going to be like, oh yeah, you can just go diagonally from here to here. But that's not actually true, right? Because we've got a unit here who's probably close enough to block him. So our navigation system is going to be like, oh yeah, like you can totally just do that. But it's not really the case. And so this is one of the bugs I'm talking about just by doing it this way. So again, it will work, but you're going to get some weird issues or getting stuck on other units. And there's definitely ways around it. like I mentioned, one thing you can do is to not directly use a tile map. You can create your own where you have a smaller, tighter grid. So instead of having 62 by 62 tiles like we have here, your navigation grid could be like 16 by 16 or something smaller, so that there's a ton more points in between and it can better account for like just how many tiles are taken up. Another thing you can do, like I said, is you can detect, hey, maybe we have a unit that is like near the corner here. Well, he's on like all 4 of these tiles, and you can block all 4 of those tiles off. So that's something you can do. The problem, like I said again, is that's going to cause your unit here to feel like, oh my gosh, I have to go all the way around here just to like get here. So there's trade-offs either way. You'll have to mess with it and experiment with it to find what's right for your game, if this is the way you want to do your collision avoidance with other units. That said, there are some other fixes you can do just to make this feel a little bit better in the meantime. But let me just get rid of the toasters in the wall that we made here. So one potential fix, and I want to show you this just so you can see what it looks like. And I don't think I'm actually going to keep this in the game, in the tutorial, in the code itself. But one thing you can do is actually get rid of those diagonal connections. So you can make it so that if I'm the toaster, I can only go to these other toasters. And so if I'm a toaster and I want to get here, well, I have to go around this way, like so. So honestly, like if I were to do this in my game, or do the tile map based, like use this same system and try and implement unit avoidance as well as wall avoidance, this is one of the best ways I've found to do it. It seems counterintuitive because it seems like all your paths would be a lot blockier. You know, you do this instead of just doing this. But I've actually found that it helps a fair amount with getting rid of awkward collisions. So let me just run this and I'll show you kind of what it looks like. And the way to do that is we basically need to say that we can only connect to these tiles. So we need the connections we need to get rid of are these diagonal ones right here. So within these 9 cells, this is going to be 0, 0, the actual middle where our current unit is. So we're trying to get rid of the diagonal connections. We only want the horizontal ones. And so this is going to be 0, 0, which means this will be 0, -1, 0, 1. This will be -1, 0, and 1, 0. So basically every permutation of these coordinates that has a single 0 and a 1 or -1 in it. So those are going to be the coordinates that we need to use. So the way we'd actually code that is by coming into our pathfinding script, and instead of connecting the 8 tiles all around, including that diagonal, I would actually just change this to be 4 points in this is, I'm just going to cheat and hard code it of an array with all of these points in it. So I do vector 2, and I'd say we'll start with 0, 1, whoops, and then I'll just grab all these and do 4. So 0, 1, 0, -1, and then 1, 0, and then -1, 0. And so, oh no, not -11. So yeah, 0, 1, 0, -1, 1, 0, -1, 0. And then what we can do here is actually just add point to that. Oh, I don't need a colon there. And so what this is going to do is it's only going to connect these horizontal and vertical siblings rather than all these and the diagonal siblings. So first, let me de-toaster our tile map here. I'm surprised by how often this toaster comes into play. It's quite useful. But so let me start this up, and you'll see that our tile map still, or our pathfinding still works, but I think it actually helps like the units colliding with each other. It causes them to do some wonky stuff sometimes, but I don't know, like look at that. I'll run it again just to see, but like I said, it's always kind of seemed slightly better. The only downside is it causes units to turn a lot, and so it looks a little unnatural, but I just wanted to present this, oh my guy's just stuck there. I just wanted to present this as another way that you can do tile map based navigation for things. So just another example, I think this is pretty much all the things I wanted to cover this, just to show how you might go about doing some collision with while adding in units and avoiding them on top of already doing walls. What I think I'm going to do is actually make, if some of you don't know, I actually post all of the source code for this tutorial onto GitHub. So you can pull this project down at any point, and I have named commits for each video. So you can choose the commit that you want if you want it at a certain point. So what I'm probably going to do is just add another commit for this video, or I'll probably, actually, I'm just going to add a branch for this specific part that has unit avoidance as well included in the collision algorithm if you want to do this. But I think in the actual code for the tutorial and going forward, I'm going to make it so that we're probably not going to include that in the code. But I just wanted to take this time in this video to show you how you might do it if you were interested in doing it. And again, like I said, there are so many ways to do this, but hopefully now you have a good idea of not only how to use A* and build your own handling for it in Godot, how to do your own custom pathfinding, but you feel comfortable with it, and you've got good ideas for ways you might tweak it or change it as you need to go forward. And if you've got other stuff besides walls and enemies that you want to add, just add them to a group like this. Add them to your obstacles group and add in the handling you need in here. And it should just work. So yeah, anyway, guys, I hope this has been helpful. I hope that you, maybe this is a question you've dealt with for a long time and you've been struggling, like, how do I get navigation that also takes into effect the fact that there might be obstacles on the map? And now you have an answer, I hope. So this was something that it just took me so long to figure out, but hope it's been helpful. Thank you so much for watching. Again, if you leave a like or subscribe or a comment, that's always appreciated. Thank you for continuing to watch and support the channel. But whew, guys, we made it. Pathfinding, it's in the game. I'll see you in the next video.